How's it going, everyone? Hope everyone's doing alright today. Okay. Alright. So, today we're going to go over the review problems that I had posted before. I think what I'll do is I'll just go through the whole thing, and I'll go through the whole thing, and if you do have any questions, let me know as we go through it. Now, the exam is not there yet, but let me show you. Close that. Let me go to a different class because I just posted an exam for my calculus class, for instance, and so going to the class that I have a test up for. Like you'll have an assignment notification when it becomes available. But you'd go to quizzes right here. And so, they're first of all, I named this the wrong thing. Sorry. Anyway, so you go to quizzes, and then you'll see test 1 here. In this case, for my calculus class, it has 2 parts, but you'll click on that, and you'll see here I included like the formulas in the instructions, and then I don't know how to show it from your point of view, but once you get in there, you'll be able to take the quiz. And again, it will be a timed quiz, and you only will get 1 attempt, so make sure you have enough time available when you sit down to take it. I think I'm going to allow 2 hours, just to a little bit longer than our normal class time would be, just to allow extra time for technology concerns, needing time to upload files and such. So anyway, so yeah, when we go into where's algebra? So we go to algebra, and you click on quizzes. And I think I started working on it already, but I haven't done anything yet because I only have 1 question so far, as you can see. But I'm going to finish editing that today, and I'll make it available for everyone, and then it'll be available until like next Tuesday evening. So basically 5 or 6 days it'll be available. So again, just make sure you find a good time, that you're prepared, and that you have everything that you need to be able to complete the test successfully online, which means some way to take a photo. Yeah, and let me go back to my calculus one just to show you. I'll go ahead and preview it. And so what happens is, okay, I give them a file, or give them a question, write out answers on paper, and then upload. You choose a file, and then you go from there. So whether that's from your phone or a computer, whether you're working on a laptop or a phone, probably a little bit easier on a laptop, I imagine. But yeah, for each problem you'll be able to submit a photo of your work. Even on the multiple choice questions, that should be helpful in if you don't get the correct answer on the multiple choice, then at least you'll get the partial credit for the work that you've shown. Okay, and so you would go through and again work the problem and then upload the answer. Work the problem, upload the answer. So each upload will be for a different question. Okay. Anyway. So, yeah. That's Calculus 2 that I'm teaching, and they're working on their first test this weekend. Also, although theirs is due Tuesday, and for us it'll be due Wednesday, so it's not too different. Well, it'll be due Tuesday night. They're Monday night. So anyway, hopefully that answers your question about the format. The other thing about this test is it's partially multiple choice, but also partially show your work. So when you submit it, it's going to give you a grade. Now, this grade that you get when you first submit your test or quiz, it won't be complete because it'll only be based on your multiple choice answers. I still have to go in and grade your other work, that the short answer problems where you need to show your work and such. So that stuff won't be graded yet. So if you complete your test, you feel like you did great, and you get like a 30, that doesn't mean anything just yet, because I still have to go in and manually grade the short answer problems. So that's a little out of hand. Anyway, no, that's just bots spamming. Sorry about that. You don't have to show every single thing. Like, there's some things I don't expect you to have to write down every single step for. As long as the work that you submit to me is reasonable, that's fine. Were there other questions on the formatting or anything like that with the test? The test is Monday, technically speaking, but again, you'll have from whenever I get it published today until Tuesday night at midnight, or 11:59 basically. So you have a window during which, it doesn't matter whether you take it tomorrow or Saturday or Monday or even Tuesday next week. As long as you take it sometime in between there and get everything submitted, that's the main thing. Okay. Now that also means that we won't have a lecture on Monday next week, because that will be like our scheduled test day. So if you wanted to use that time to take the test, that's fine. If this is like the only time you have available. But also I wanted to give a larger window for people who want to take a little bit later in the day, maybe feel a little more awake than you do right now. Because certainly that would be me. But yeah. So once it's available, you can take it whenever. But remember, you only have one attempt at it, so make sure you have enough time to allow for it and to do everything. So all right. So, if there aren't any other questions, let's go ahead and get started on these problems. There will be. In fact, I think in this first test I actually have a bonus question, and assuming I figure out how to set that up inside the quiz format, but yeah, not beyond just like a bonus question on a test, there'll be other opportunities throughout the semester. But main thing I would say is just focus on getting through this test first, and we'll worry about the other stuff later. Well, that's normal. Okay. Now, the first problems on the exam are all working with quadratic equations and solving quadratic equations. On these problems, you're not really tied to any particular method as long as you're able to arrive at the solution. Although in most of the cases there will be a particular method that will work better than others. So in this one, anytime we see just a plain x squared here, right, on Monday there won't be class because that's basically the day of the test, and I at least give you one class period to actually take the test if you prefer to do that at the scheduled time. Okay. Anytime we see the x squared here, some you'll actually need to use the quadratic formula, so not necessarily factorable. But for this one, if we look at what multiplies to negative 18 and what adds to plus 7 in the middle, can we think of a pair of numbers that works for that? Nine and minus 2. Yeah. 9 times negative 2 is negative 18, and 9 plus negative 2 is 7. So we can set up our factorization. And then our two answers then are x equals -9 and x equals 2. Okay. Problems that you see on the review are essentially just like the problems that will be on the test. It'll be a similar similar type of questions. It'll just be like different numbers and things. Okay. Okay. So problem 2, we have x times 3x plus 7 is equal to 6. Now, we can already see something's very different about this problem than the previous one that we just worked. A couple of things are different. First thing, we'll want to make sure we go ahead and distribute our x. So it's 3x squared plus 7x. And then we have a 6 on the right hand side, right, and we can subtract that from both sides. So 3x squared plus 7x minus 6 is equal to 0. Okay. Now, whenever we want to solve these, it's best to get it equal to 0 first, and we can go from there. Now, this may be factorable, but it's hard to say because we have the 3 in front of the x squared. In this scenario, I would almost say just go ahead and use quadratic formula if you want to play it safe. In fact, this may not even factor. I think it does factor, but it's probably not an easy factorization. But if you want to try to go through and guess and check, that's perfectly fine. Otherwise, I would suggest that we go ahead and use the quadratic formula here. Okay, so we have our formula. Even though most of you probably already know this particular formula by heart, it will be included in the test, so you'll have it available. Okay, so negative b would make that a -7. B squared would be 7 squared, or 49. Minus 4. A is 3, and B is -6. And then we have 2 times A on the bottom, which is 2 times 3 is 6. Well, this may not actually be factorable, but we'll see how it goes. We'll know if it's factorable or not if this is a perfect square under the radical. Now, we have 49, and then we have -4 times 3 times -6. So we see that there's 2 minus signs there, so we know that's going to change to a plus. And then if we take 4 times 3, that is 12, and 12 times 6 would be 72. Yeah, that's going to add up to 121, which is perfect square, so this would have been factorable if we wanted to do it that way. Okay. Yeah, so 1 square root of 121, we know that's 11. So we end up with -7 plus or minus 11 divided by 6. Now, So we want, when we have the plus or minus, of course we want to split it up, one with plus and one with minus. Negative 7 plus 11 is positive 4 over 6, gives us 4 over 6. Negative 7 minus 11 is negative 18, divided by 3 is negative 3. And instead of 4 over 6, we could go ahead and reduce that and say 2/3. So we'll say x equals 2/3 and negative 3. Right. Yeah, we definitely simplify any fractions that we have, make sure they're in lowest terms. If it's an improper fraction, like we had 6 over 4, we would still be okay writing that as 3 over 2. So we can reduce it, or we have to reduce it, but it's not necessary to change it to a mixed number if it's improper. Okay. Now, if you got to this and you wrote your two answers down as these two numbers without reducing, generally what I do is I count each question as 10 points, and then I would take off like 1 point for that. Yeah. So it's not a major thing, but again, I'm going to make sure all the details are there. And that's really part of why we learn math in the first place, is paying attention to all the details that are in a problem, and just being successful problem solvers, taking the question from the beginning all the way through to the end. And so it'll be a minor deduction there, so 1 point out of 10. But I mean, we would like to get all the points that we can get possible, certainly. Okay. Let's go on to problem 3. Here we have x minus 2 in parentheses squared plus 4 is equal to 5. Now, this problem, really, there's two ways that we can work this. And honestly, it doesn't matter which way we approach it. As long as we're able to arrive at the correct answer, that's still the main goal. Whether you take one route or another is not as important. Okay, I'm not requiring any particular method on these. But there is one method that absolutely is going to be easier than the other method here. Okay? And it may not be the one that you initially think of. So we have to keep that in mind. Whenever we see a term being squared like this, we really have two options. One option is, well, if we can get these numbers all over to the right-hand side, then with the square on the left-hand side, we can just take the square root of both sides and just use the square root property. What a lot of people tend to try to do in a problem like this, from what I've seen in previous classes, is another option is we could just multiply this out, x minus 2 squared, or x minus 2 times x minus 2. Multiply all that out, add the 4, pull the 5 back over, combine that and get a trinomial, and then factor and get the answer. That works, but it's kind of a longer method. I would suggest here, let's just go ahead and subtract the 4. So x minus 2 parentheses squared is equal to 1. Now we can go ahead and take the square root of both sides. Taking the square root cancels out the square, so we're just left with x minus 2 equals plus or minus 1. Now when we take the square root of both sides, that means we incorporate the plus minus there. From that point, we branch it off into two problems. X minus 2 equals 1 and x minus 2 equals negative 1 to represent the plus minus option there. And from that point we just need to solve for x. So add 2 to both sides for both equations. Okay. And so that gives us x equals 3 and x equals 1. And that would be our two solutions. Now, when we solve that, again, we had a couple of options, and that's just one of them. Let me go ahead and show you the other one that I see a lot of people want to try. So we're taking that same equation, but what I see others try, and this is fine, it's just it requires a little more work, I think. Since it's x minus 2 squared, we go ahead and multiply it times itself. So x times x is x squared, minus 2x inside, minus 2x outside, so minus 4x. Minus 2 times minus 2 is plus 4. Okay. Then we go ahead and combine our like terms. Subtract the 5 over. And so we have x squared minus 4x plus 3 equals 0. From that point, it's just a question of factoring. And so we think of, okay, what multiplies to 3 and adds to negative 4? And that will be, what is it, negative 3 and negative 1? So x minus 3 times x minus 1, and we get x equals 3 and x equals 1. So we get the same solutions in both methods. So we see that as long as we're able to get the solutions, then the method doesn't really matter. But overall, I think the completing this, or not completing, I think the square root method is a lot easier than all the different mathematical operations that goes into doing it the other way. So, where we have to square a binomial, where we have to combine all of our like terms, and then end up having to factor from there. Okay, so that's 3. Problem 4, we have 2x squared minus 2x minus 1 is equal to 0. Now in this case, we again have a trinomial equal to 0. I don't think this one is factorable. And again, because we have the 2 in front of the x squared, I would recommend, let's just go ahead and play it safe and use the quadratic formula to solve that. Our factoring approach that I've been using only works if the number in front of x squared is 1. So anything else, we can't use the same approach. Alright, so x equals, now b is negative 2, so negative b is the opposite, which makes it a positive 2. Negative 2 squared is a positive 4, minus 4 times a times c. And then 2 times a is going to be 4 on the bottom. Now, from this point, we go ahead and simplify under the radical, as always. Then we notice that we do have two negatives here, so two negatives will turn that into a positive. And then 4 times 2 times 1 is 8. So we end up with a 12 under the radical. Now we know 12 is not a perfect square, but can we simplify that term? And the answer is yes, but how would we simplify that term, I guess, is the better question. Four and 3. Yeah, we know, right, we know 12 is 4 times 3. And so the 4 we can actually take out of that because we can take the square root of 4, which is 2, and still leave the 3 under the radical. So we have 2 plus or minus 2 square root 3 divided by 4. The last thing we need to do here is simplify. What can we reduce each of these numbers by? Two, yeah. Now, it feels weird because we have this square root of 3 over here, but we look at the numbers on the outside. We have 2, 2, and 4, and they all have a 2 in common. Now, because these are multiplied together, we don't have to change both terms as long as we can change the term outside. So, basically, we think of this as 1, 2, 3 terms in this problem. And so, looking at these 3 terms, what number do those 3 have in common? They all have a 2 at least that we can factor out. For instance, if we factor out the 2 on the numerator, we would be able to factor out the 2, so it's 1 plus or minus 1 times the square root of 3. Just dividing 2 out of both terms, so it leaves them both as 1s. And then the 2 and the 4 can now reduce. Okay? And so if we reduce that, that'll leave just a 1 on top and a 2 on bottom, because 2 over 4 is 1/2. Yes, and then we look at the statement and we just have a lot of extra 1s here. We don't need this extra 1 multiplying because we know 1 times anything is equal to that same thing. And then likewise here, we don't need this 1 because it'll be implied. So we could actually write our answer like this, and that'll probably be the most efficient way of expressing it. But again, there's 2 ways we can think of this simplifying right here. One is to factor out a common number on top and then reduce it with the bottom, like we did here. The other way is we can just take, knowing that we're working with these 3 numbers, just divide all of these by 2, so we get a 1, a 1, and a 2, which is what we end up with in our answer. So there's a couple of different ways of thinking about that and expressing it. But both of them will lead to the same point. Now, what I see some students try to do that is incorrect is they'll reduce the 2 with the 4, and then they'll reduce the other 2 with the 4 separately. We can't treat them separately because they're being added or subtracted in the numerator, so they're really considered one large object. Okay. Anyway. Yeah, so that would be our answer there. Okay, for 5, we have 3x squared minus 2x plus 1 is equal to 0. Alright, and again, with the 3x squared, we'll have to use a quadratic formula. Let me take out one of these quadratic formula problems. I don't know. It seems like an awful lot. But hopefully they're not bad, so maybe I'll leave them all in there. Just anyway. I'm still debating getting rid of one of these. We have b is negative 2, so the opposite of that would be a positive 2, so negative b would turn that to positive. B squared, negative 2 squared is positive 4. A is 3, C is 1, and then 2 times A, 2 times 3 will be 6 on the bottom. And the same thing here, we want to make sure we simplify what is under the radical first. We have 4 minus 12. Now, that ends up being a negative 8 under the radical. And if we have a negative under the radical, what type of number is that? Imaginary, right. And so, knowing that that's going to be an imaginary number, we know the negative will become an I, exactly. The other thing, though, is we do want to simplify the square root of 8. Even though 8 is not a perfect square, it does have a perfect square as a factor, so there should be a way to simplify this expression. We know it's 4 times 2, good. And then again, we can take the square root of the 4, which brings a 2 outside and leaves the other 2 inside. So, well, close enough. It's 2 square root 2, yeah. So again, the square root of 8, the square root of 4 times 2, and then square root of 4, we make a 2, and then the other 2 is underneath the radical still. And so that's what we end up here. And we still have a 6 in the bottom. Now, this time we have a 2, a 2, and a 6, so those all have a 2 in common. Let's just divide everything by 2. And so that leaves us with 1 plus or minus I times the square root of 2 over 3. Now you'll notice on the test, this particular problem is a multiple choice question, and so we find the one that matches the answer that we came up with, and we would enter D as our answer. Now, if D had ended up not being correct, or maybe we made a sign error and we picked A by mistake, thinking that this was a negative when in fact it should be a positive. So if you pick A by mistake, but then you show all the work that we just did in our paper, if you turn that in as well, and then in that case, I would give you all the credit for getting the right answer here, even if you picked the wrong answer in the multiple choice. Because that's really just, I mean, you've done all the work right, and that's the important part, is doing the work right. picking the correct one in a multiple choice test. It'd be nice to have 100% accuracy there, but again, I'm looking for how the work is being done and how y'all are progressing as students solving equations. So, okay. So 6x squared minus 2x plus 26 is equal to 0. Now, we look at this, okay, we have a 1 in front of x squared, so our thought is, well, how do we factor the 26 to come up with a negative 2? Now, it turns out that's not possible in this case. This is actually not a factorable expression. So instead, we would go ahead and use the quadratic formula to solve this. So negative b is positive 2. I don't know why I keep using negative 2 there, but anyway. Negative 2 squared is positive 4 minus 4ac. And then 2 times a is 2. And we look at what's under the radical, and we have 4 minus, and then 4 times 1 times 26. So that's 4, and I believe that's 104. Okay, so we end up with 4 minus 104, which actually gives us a negative 100 under the radical. Okay. And so we think of the square root of negative 100, well, it's the square root of 100, which is 10. And then because it's negative, we again know it's imaginary, so we'll put 10i. So 2 plus or minus 10i divided by 2. And then we can just divide each of these numbers on top by the 2 on bottom. So x is 1 plus or minus 5i. That one's similar to 5, but probably a little bit more straightforward as far as how to simplify, because we actually just have a perfect square under the radical other than the fact that it's negative. We're still able to get a root either way. Okay. So for 7, 4x squared minus x minus 3 is equal to 0. Now, this is a multiple choice question, and it says we want to, or asks us to determine the number of real solutions using the discriminant. No, the review is just for practice. Plus, since I'm showing you how to work out the whole thing, it kind of defeats the purpose of having you turn it in. Okay, now this is again a multiple choice question. Now let me show you the three choices that we have here. We have 2 real solutions. We have 1 real solution. And we have 0 real, which corresponds to 2 imaginary. Now, the discriminant, this is a formula I'll give you, but the discriminant is b squared minus 4ac. Okay? Now, we want to calculate that for this particular equation. Now, in order to calculate this correctly, we have to make sure this is all multiplied out and equal to 0, like all the other problems that we've solved so far. Now, which it is, so we don't have to worry about it, but in general it's a concern. B squared would be a negative 1 squared, which is 1, minus 4, A is 4, and C is negative 3. So we have minus and then another minus, so we know that's going to be a plus. 4 times 4 is 16, times 3 is 48. And so our discriminant is a positive 49. So if we have a discriminant of 49, what does that tell us as far as the answer? Okay. Well, this is something we have to know. You know, even though the formula will be given to us, how we interpret the formula is not given to us, and that's really what we have to focus on understanding in order to successfully answer this question. So 49 is a positive number. If the discriminant is greater than 0, we would choose option A. If it's equal to 0, we would choose option B. And if the value we get is less than 0, we would choose option C. Since this is a positive number, we know A is the correct answer. Okay? Okay, 8, 2 plus the square root of 3x plus 7 is equal to 9. There we go. In this case, what should happen first? Our goal is to solve for x, as always. Let's subtract the 2. So we have square root of 3x plus 7 equals 7. Now the reason we would want to choose to subtract the 2 is whenever we're solving a problem with the radical, such as this one, we want to get the radical by itself. In this case, the square root of 3x plus 7 needs to be by itself, and everything else on the right-hand side. And now we can square both sides, yes. So we'll go ahead and square each side of the equation. Now on the left-hand side, if we square the square root, that's just going to cancel out the square. So we just have 3x plus 7. And on the right, if we have 7 squared, that is 49. Okay. Once we get it out of the square root, and we just have a normal equation, It's really just a question of solving the problem how we normally would. This is a linear equation, so the goal is to get x by itself. So we can subtract the 7 and then divide by the 3, basically. Those could happen in any order, but that's probably the easiest order, is to do the subtraction or the addition first and then do the division last. And so finally, if we take both sides and divide by 3, we end up with x equals 14. The other thing that we want to keep in mind working these square root problems is that because of the way that we solve them, sometimes we arrive at solutions that are not necessarily true answers. So we always want to make sure we plug this back into the equation and verify that it comes out to give us the correct value. So we want to take x equals 14, for instance, and plug it in here. 3 times 14 is 42, plus 7 is 49. Square root of 49 is 7, and then 2 plus 7 is 9, and that's a true statement. 2 plus 7 is equal to 9. So we know our x equals 14 is correct. Okay. Now we have a second problem with a square root. You see it here. Square root of 2x minus 7, and then plus 5 separate from the radical, and that's equal to x. In this case, we'd still use the same approach. We want to get the square root by itself, so we'll go ahead and subtract the 5 from both sides. So the square root of 2x minus 7 equals x minus 5. Now again we can square. So that cancels out the root on the left hand side. Now, where we want to be careful is when we say that we square both sides of the equation, that means if we have multiple terms, like we have an x and a minus 5 here, we want to put that in parentheses and square it, as opposed to squaring each term individually. So when we square both sides, we square the entirety of each side as a parenthetical term, basically. Alright, so if we square x minus 5, we know that's x squared minus 10x plus 25. Because we have a quadratic equation, we know that we need to get everything to one side equal to 0. But the other thing that we want to consider is that we want the x squared term to stay positive. So if we want that to stay positive, that means everything on the left hand side will have to move over to the right hand side. So we'll subtract our 2x. And at the same time, if we want, we can add the 7. So putting that together, we get x squared minus 12x plus 32. Now we can go ahead and factor and solve, and we'll still need to check afterwards, but let's get it solved for it first. So think of what multiplies to 32 and adds to negative 12. What would that be? Negative 8 and negative 4. So we're going to x minus 8 and x minus 4. as our two factors. And so we arrive at x equals 8 and x equals 4 as the solutions. Now once again, we need to check our answers. In these problems where we get two answers, it's a little bit more likely that one of them is good and one of them is not good. Okay, it is possible that both of them are valid solutions, but we're not as sure in this instance as we might have been in problem 8. So let's check x equals 8 first. So we know it's going to be 8 on the right hand side because that's what x is. So we'll plug in our 8 here, and so if the left hand side is also equal to 8, then we should have a valid statement. So 2 times 8 is 16. 16 minus 7 is 9. Square root of 9 is 3. And then 3 plus 5 is x, which is our 8. So 8 equals 8. So x equals 8 actually checks out. So we repeat this with 4. 2 times 4 is 8. 8 minus 7 is 1. Square root of 1 is 1. And then 1 plus 5 is 6 on the left-hand side. And we plug in x equals 4. We get 4 on the right-hand side. So is 6 equal to 4? Certainly not. So in that case, we can rule out 4 as a solution. And so we see the only valid solution here would be x equals 8. All right. Let's see what we have next. This, in the instructions, you can see it's called a quadratic-like equation. We have x to the 4th minus 13x squared plus 36 is equal to 0. Now we look at how we can try to factor and solve this, because it's similar to a quadratic equation in that the same methods for solving can apply. And so this one's actually factorable. So we think about what multiplies to 36 and then adds to negative 13. And that would be negative 9 and negative 4. Good. So x. Now, we know the factorizations minus 9 and minus 4. The question is, how do we split up the x to the 4th and make these two expressions here? If it's x to the 4th, we know it's not just x and x. What would we put there instead? X squared. Good. There's two ways we can figure out what goes here. One, we can just take half of this number, which is x squared. The other way is whatever his term is in the middle, that's going to be in both places, which is x squared. So either way we look at it, x squared is the correct term for both parts. Now, we still have to solve the remaining parts here. So by setting those equal to 0, we basically get x squared equals 9 and x squared equals 4. So what then are the 4 solutions to this problem? Three and negative 3, 2 and negative 2. Because the idea is that we're actually going to take the square root of both sides there. So we get x equals plus or minus 3. And x equals plus or minus 2. Now we can write those as plus or minuses, or we can write them as separate solutions. 3 and negative 3, 2 and negative 2, either way is fine. You're close. It'd be x plus 3 and x minus 3. Yeah. The other way is, definitely we can still factor these, because these are differences of squares. We can factor them into a pair of binomials. We'll still arrive at the same solutions. But again, there's different ways to do it, and both of them in this case are equally valid. So. Any questions on that one? Okay. So problem 11, we want to know which of these coordinates is not an intercept for the equation y equals x squared minus 4x minus 12. Now, that means that there's 3 intercepts and one that is not an intercept in this group. So only one of these can be the correct answer. Now, for our y-intercept, remember that we want to plug in x is equal to 0. So if we take x equals 0 and plug that in here, well, actually for both x's, we get y equals 0 squared minus 4 times 0 minus 12. So we get y equals negative 12. So if we think about it, we plugged in x equals 0, we got a value of y equals negative 12. And remember, we write our answers as ordered pairs, where the x value is first and the y value is second. And so we get 0 and negative 12. Okay. Now, we look at that, okay, we see the answer here. But again, remember, well, 2 x-intercepts and 1 y-intercept. That's what it boils down to. Yeah, we can only have 2 x-intercepts, Gabriel. So we remember that we want to choose which of these is not an intercept. So as soon as we get one that shows up on the list, it doesn't mean that's the answer. In fact, finding 0 and negative 12 as the y-intercept actually eliminates that as a possible answer. Okay, because we want to find the one that's not an intercept. Yeah, if you look at the graph, it may be a situation such as this, where it crosses the y-axis once and the x-axis twice. And that's probably what we're looking at here, something this way. Okay, but you were absolutely right. That an exponent of 2 tells us that we have 2 solutions, but that only refers to solutions for x. We still have another solution that works for the y. So now we look at the x-intercept, and again that may be plural in this case. If we're trying to find the x-intercepts, then we'll plug in y equals 0. And by changing y to 0, essentially we have a problem much like the first 6 or 7, I think it was 6 problems on this review, which is we have to solve a quadratic equation. And this one will be factorable. I'm not going to give you anything that's not factorable at this stage, because there's so much else going on in the problem already. But we do need to figure out what multiplies to negative 12 and adds to negative 4. So what numbers do we get there? Negative 6 and 2. Good. So x minus 6, x plus 2. And so our solutions are x equals 6 and x equals negative 2. And that means since we plugged in y equals 0, that's our y value, and then we got 2 different x values. So 6 comma 0 and then negative 2 comma 0. So now, that means we can take these 2 answers we just got here and then eliminate them from our possible solutions here, so it only leaves one answer, which that's then our correct answer to this problem. This kind of problem, and there will be others later, I like to give them as a question of not which one is correct, but basically which one is incorrect. It does make us work a little bit harder in that regard, and it also makes it where it's not as easy to just plug in the numbers and see what works. Although that actually does work in this scenario. When you figure out which pair of numbers we plug in is not true, I guess that's a way to approach it. But I would prefer that you go through and you find the intercepts and figure out which one is not on that list. Okay. Getting closer to the end here. I think we just have number 12, and then we have the bonus question. Here we want to find the center and the radius for the given equation of a circle. Now, again, if you're looking at the actual review, I've given this as a multiple choice question, which means I'll also give it as a multiple choice question in the test itself. This one you can't really just plug in numbers and figure out what works, though, because it does require some effort to figure out what these numbers are for the center and the radius. But it does, I guess, if you're not sure, open up the possibility of guessing. So there is that. On the multiple choice problems, definitely answer every single one of those, even if you're not sure. If you get it right, then I'll give you credit. And the only time I'll deduct credit is if you don't get the answer right, and then you only get partial credit for the work that you've shown. Okay. Or if you haven't shown any work, then you just don't get any credit. So that's something to watch out for. So I've had students in the spring semester, when we, after the halfway point we went online, they would turn in tests where even the multiple choice questions were left blank, and really there wasn't anything I could do for them at that point if they're not willing to work, unfortunately. So things are a little bit more crazy, I think, in the spring semester, but hopefully we're kind of settled into everything, and we're working okay. Now we did talk about this one on Monday, but again, our strategy is we want to group our x's and our y's together separately. So x squared minus 12x, we'll get those together. Y squared and 2y. Almost there, Brock. Yeah. And then our 12, let's subtract that over to the right. The reason we do that is we don't want to incorporate in either one of these parentheses, so it's easier just to move that number to the right hand side. Okay, now we have to complete the square inside each set of parentheses. Yeah, the 4. The 4 is what you have wrong there. And the right hand side. Yeah. If we complete the square, remember we take whatever's in front of the x or the y, negative 12 in this case. We divide that number by 2, which gives us a negative 6. And then we square that result, and that gives us a 36. Okay. So that means we'll have x squared minus 12x plus 36. So using that same approach, what number would we end up adding to y squared plus 2y? One, yes. Again, we take our 2. I didn't mean to draw that one, sorry. Take our 2 and divide by 2, which is 1. Take this 1 that we got as a result and square it, and it's still 1. Okay? Now over on the right hand side, because we've added 2 numbers to the left hand side, 36 and a 1, we want to make sure we add those same 2 numbers to the right hand side. And the reason we do that is if we add something to one side, we have to add to the other to keep the equation balanced. Because we want it to remain equal, and that's what we have to do in order to maintain that equality. Now, we can factor each of these pairs of parentheses. We can factor it as 2 identical factors, so we should be able to write it as a binomial squared. So we're thinking about what multiplies to 36 and adds to negative 12. 8 times 4 is 36. Or rather, is it 32? Negative 6 and negative 6. Again, the key here, and hopefully this helps, the factorization should be identical if we've done everything right. It's okay. So we end up with x minus 6 squared. A very similar situation happens on the other term. You know, what multiplies to 1 and adds up to 2, well, that's just 1 and 1. So we can write that as y plus 1 squared. Meanwhile, over on the right-hand side, we have negative 12 plus 36 plus 1, and that gives us 25. So the center of the circle, again, we take the opposite of these two numbers, so it's positive 6 and negative 1. Good. Again, this is x minus 6, we get a positive 6 there. This is y plus 1, so that gives us a negative 1. What about the radius? We know the radius comes from the right-hand side, but it's not 25. Good. Alright, and then there's a multiple choice problem, and we'll just pick out the correct answer from there. Yeah, from the beginning, we just got our x's together in parentheses, we got our y's together in parentheses, moved the number over to the right-hand side. Then we went through completing the square process for both sets of parentheses. And we factored each of those, and since they're both what should happen here is both of these are identical for both parts. So we should have a single binomial that we can write as a square in both cases. That then gives us the center and the radius. Okay. And then just to wrap up, let's look at the bonus question. Now, this is not actually a bonus question, but there will be a similar problem that is a bonus question on your exam. So we have x to the 2/3 plus 4x to the 1/3 minus 5 is equal to 0. Now, again, we're doing a factorization. This is a quadratic like, meaning it's not quadratic, but we can solve it using the same approach. So we need two numbers that multiply to negative 5 and add to positive 4. So multiply negative 5, add to positive 4, and that would be close. Remember, they add to a positive 4. There you go. Yeah, it's 5 and -1. Now, in order to get, so we notice we multiply 5 times -1 is -5. But if we take 5 and -1 and add them together, that gives us a 4, a positive 4 specifically. Okay? So in our factorization, we know one of these will have a +5, the other will have a -1. What, again, this is quadratic. So this is like our x4th problem that we had before. So if we have x to the 2/3 plus 4x to the 1/3 minus 5, what is going to go in the first part of each of these parentheses? X to the 1/3. Good. I'm not quite sure what you're trying to express there, Brock. Well, you are right. We are looking at cube roots, and that's the other thing is that, you know, if we have x to the 1/3, remember that's the cube root of x. Okay. So x to the 1/3 is the same thing as the cube root of x, and if we have the cube root of x equals to a number, how do we get rid of a cube root? We'll go ahead and cube both sides. So we cube that. Cubing the cube root gets us back to an x. And so we want to have -5 to the 3rd. We'll repeat the same process for the other term. So we'll have x equals 1 to the 3rd. And so -5 to the 3rd is -125. 1 to the 3rd is just 1. And so that will be our solution, just those two numbers. Okay? Any questions? So the problems that you see in your exam should be pretty much like the ones that we're looking at here today. As far as the types of questions being asked, the actual questions would be a little bit different, of course, because I don't want you to have it quite so easy. But, you know, I want to challenge you a little bit. But yeah, I think we'll be all right. All right. One last thing. You might have seen him today. You might have heard him today. You didn't see him. He's in the other room. But there's a picture of my dog. So he's a little barky at times. So I apologize. I don't know if y'all can hear him or not. I don't know if my microphone picks him up. But anyway. Rocking his bow tie. That's his Easter bow tie. Anyway. So, everyone, have a good day. Good luck on the test. And again, you have a pretty large window during which you can take the test. So if you do have questions, make sure you send those to me first before you go into the test. So, y'all take care. And Again, no class on Monday. It's just opportunity to take the test if you want to do it then. So I will talk to you again next week. Have a good weekend and good luck on this thing.